Okay, so I want to quickly take up a question from page 5, 2D right here. So 2D right here, um, there's two different ways you can do this question. One way, you know that a triangle adds up to 180. So if this is 75, this is 40, you know that this third angle in the triangle is 65. And then from there, using the supplementary angles, if this part is 65, that means this part is 115 when you subtract it. The other method you can do is called the exterior angle theorem, EAT, EAT. Okay, what it is the two inside triangle angles always add up to the exterior angle on the opposite side. Okay, so if you just add up 40 and 75, you will get X. This is actually a very important theorem because if they didn't give you these numbers and they gave you an expression like these ones, x plus 10, x minus 30, and so forth, then you need to know this relation between those three angles to solve it. Okay, so keep that in mind. I've seen it on EQAO before, so you can, I wanted to point that out. Okay. The other one I wanted to point out, there were some questions regarding this one. This is A and B are not 45, 45. This line does not suggest that it's cut in the middle. You can't assume that it's cut in the middle. But if you look at like triangle by triangle, you can see that this right here is an isosceles. So in this isosceles triangle, if this is 42, that means A is 42. And since A is 42, that means B is 48. Okay. And then looking at here, this is not an isosceles triangle because it doesn't have the second tick. However, this is a 90-degree right triangle. So if you know that this is 90, this is 55, then that means this is 35. Okay, so just wanted to point that out from the homework. One last thing I wanted to go over. So for example, something like this. Give me an estimate. How big do you think this angle is? Just a quick little estimate. Yep. 60? Sure. What about an angle like this? How much do you think that is? 160. Sure. Okay. What I want to point out is when you see an angle like this, you know it's an acute angle. So your answer should be less than 90. Same thing with this. I know it's an obtuse angle, so my answer should be more than 90. When some of you were asking questions yesterday, and you were trying to solve for an angle like this, for example, and some people told me it was 100 degrees. Is it possible? No. Okay. So you know the number you're looking for, what it should be around. This angle to me looks like around 45 degrees. And the correct answer to this was 35. Okay. So I wasn't like way off. Okay. So when you give your answer, just do this quick little double check. It will save you some mistakes. And another thing I want to point out, another hint. Remember we had like these diagram right here. So let's say this is 30 degrees, then this side would be 150. When you have parallel lines, like I would say 90% of the time, all the other numbers in like your diagram is just going to be either 30 or 150, 30, 150. It's just going to be the same number. Okay. So just, I don't even need to know any pattern. I can already tell this is an obtuse angle, so it has to be 150. This is an acute angle, so it has to be the 30. Okay, so just a little hint for you guys. Okay, so moving on to today's lesson, page 6. This diagram right here, memorize it. Okay, I will test you guys on these words. Okay, what it means or label. Okay, but I will be asking you guys this diagram. So make sure you you memorize it, you remember the spelling. Yes, spelling counts. It's great. You guys are grade 9 now. So an arc is any part of the circumference. So it could be here, 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 any of those. Circumference, as we know already, is the perimeter of the circle. Radius is from the center to any part of the circle. Diameter is twice your radius, or the line that goes right across the middle of your circle. Secant, this line right here. And a chord is this line right here. What's the difference between chord and secant? Right, good job. So a secant cuts through. Okay, it goes on forever. A chord has endpoints on the circle. Tangent. Tangent is this one on the outside that only touches one point of your circle. And then central angle and scribe angle, these two we will talk more about tomorrow. Okay, tomorrow. But again, make sure you memorize this circle, the spelling, the labeling, the definition. Okay, remember it. So let's go over some examples on page 7. Okay, let me zoom in. Okay, page 7. Point O is the center of the circle, and AB is the tangent to the circle. So this is one of the properties of a tangent line. So a tangent line and the circumference always makes a 90-degree angle. Right? So tangent, radius, always makes a 90-degree. Okay? And radius. Sorry, not circumference, radius. They should say radius. So the tangent and the radius always makes a 90-degree angle. Okay. So if I know that angle AOB, okay, is 63, then I want to find angle OBA. A lot of people have trouble, and on the test they always ask me, Miss, which angle are they looking for? So OBA, trace it with your finger. OBA, that means it's this angle, the angle in the middle. Okay. So what is it then? If I know that this is 90, this is 63, what's B? Yeah? Yeah, 27 degrees. Good. Radius. Okay. Again, make sure you include the unit degree sign. Okay. Second. So since this is a right angle triangle now, so we have a triangle, right angle triangle, and a circle. When you hear right angle triangle, what comes to mind? Pythagorean theorem. That's it. So this, I know that this is 20 centimeters and this is 15 centimeters. So to find the radius, I do Pythagorean theorem. Okay. If I'm looking for the radius right here, OC, should I do the adding one or the subtracting one? Michelle? The subtracting, because this is my 90-degree angle. Across from it, this is my hypotenuse. So if I'm given hypotenuse, I'm doing the subtraction. So 20 squared, take away 15 squared, square root it, you get A is 13.2 centimeter. Alright, so these two properties, you could only solve it because you know that the line is a tangent and because you know this property, that it makes a 90-degree angle. Okay. So all this is new to you guys. So even if you're good at math in grade 8, you guys didn't learn about circle properties. Right? So, and this is new to the curriculum. Okay. Next one right here. Oops, I'm trying to cover up what I wrote. Okay, so an airplane A is cruising at an altitude of 9,000 meters A cross-section of the Earth is a circle with radius approximately 6,400 kilometers. A passenger wonders how far she is from the point H on the horizon as she sees outside the window. Calculate the distance to the nearest kilometer. Okay, so first off, looking at this diagram, what's the very first thing I should pick up? Yep. One's in kilometers and one's in meters, right? So I have to convert one of the units to the same. So since you guys just had a whole test on conversions, this is easy peasy lemon squeezy for you guys. What's 9,000 meters in kilometers? 9K, good. Divided by 1,000. All right, remember kind hungry ducks usually don't chew much. So it's 1,000. The ratio is 1,000, so we divide it. Okay, so I want to figure out how long is HA. I know that this whole length right here is 6,409. I know that this part is 6,400. How do I know this is 6,400? What is that in the circle? The radius. That's right. Good job. So remember, your radius is the same throughout your circle. So right here, they told you this part is 6,400. That means this part is also 6,400 because it's your radius. Okay, good. So Pythagorean theorem, I am doing the subtraction. So when I calculate it, you get 339.5 kilometers. Okay, obviously the diagram is not drawn to scale. Okay. Okay. I'll give you guys a second to copy this down. Okay, Ahira, you copying this down? Okay. What? Okay. Example 4. Point O is the center of the circle. A line segment bisects chord AB. Angle OAC is 33. Determine the value of angle X and angle Y. So first off, what does the word bisect mean? Think of science. Cuts through, more specifically, split in half, right? So it's cutting in half, not just cutting it, but in half, exactly half. That's bisect. So it's like when you bisect the worm in science, yeah. Okay, so OC is the bisector, so it cuts it through. Whenever you cut it through, it does make a 90-degree angle. This is actually another property. Okay, so whenever you have a chord and you bisect it from the center, it always makes a 90-degree angle. Okay? So I know that OA and OB are equal. Again, how do I know they're equal? Right. So how do I know? You answered the last question. OA and OB. How do I know those two lines are equal? So I just added in those two lines for the isosceles. But how do I know it? How do I know it's isosceles? Okay. Any triangle that I draw from the center to a chord is always an isosceles triangle because OA is your radius, OB is also your radius. So that means those two sides are equal, which means it's an isosceles triangle. So if this is 33, that means X is 33. And reasoning, isosceles. Okay, and then now just looking at triangle OAC, this is a right triangle. So that means Y is 57 degrees because of the right, because it's a right angle triangle. Okay. So notice like for this question right here, I only gave you one number. I only gave you the 33 degrees, but you had to apply all those properties to know, to figure out everything else. Okay? And you can't do that unless you know the properties. Okay. Example 5. So point O is the center of the circle. AB is the diameter with 26 centimeters. CD is a chord that is 10 centimeter from the center of the circle. So this line right here. Oh, sorry. This line right here, CD is the chord. Oh, wait, did I make it? Oh, okay. So this is 10 centimeters. It's labeled in the picture. So 10 centimeters is OE. OE is 10 centimeters. What is the length of the chord CD? So I want to figure out how long this is. Okay. So I'm actually looking at a triangle like this. If 26 is my diameter, that means 13 is my radius. So OB is 13, which means OD is also 13. Okay. Diagram is not drawn to scale, right? Because if I look at it, OB looks shorter than OD, but they're actually the same length. Okay. Again, it's because it's your radius. Radius is the same throughout your circle. So Pythagorean theorem, I can figure out how long ED is. 13 squared, take away 10 squared, I get 8.3. So how long is line CD? Sam? So what I just found was ED. Yeah, so ED is 8.3.
Would be 16.6 since 8.3 would be times 2.
Right. Okay. And why is that? Because we just learned up here that it bisects. Since it bisects, it means that these two lengths are equal. Okay. So again, just applying all these properties. Okay, last example for today. Usually I don't do like 6 examples, but each one of them are important in its own way. Although you can see a lot of it is just Pythagorean theorem, Pythagorean theorem, Pythagorean theorem, and radius. Okay, so recognize that the radius is the same throughout the circle, just like right here. Okay, surface of the water is 24 centimeter wide, so I know that A to B is 24, which means A to C is 12 because it bisects it. And I'm looking for the length of OC. Okay, so basically my right angle triangle looks something like this. Square it, subtract it, square root it. I get A to be 16. Okay, and then, oh, you have the idea?
CP is 4 centimeters.
How did you know?
Radius is 20 centimeters, so 20 minus 16 is 4.
Good job. Okay, I'm looking for how long CD is. So as Sydney said, AO is 20 centimeter, which is your radius. And so OD is also 20. So the whole length right here is 20. It doesn't look like it, but it is. All right, so OD is 20, and you know that this part of the triangle is 16. So when you subtract it, that means the water depth is 4 centimeters. Okay. So like in terms of the math, it's not hard because all of it was just Pythagorean theorem, Pythagorean theorem, Pythagorean theorem, Pythagorean theorem. So it's just all using Pythagorean theorem. But the hardest part is to just picture it in the diagram. Okay, to see to see that right angle triangle. Okay. One last thing I wanted to point out. OE, this line itself, is called the perpendicular bisector. In grade 10, you guys prove that this is a 90-degree angle. Okay, so in grade 10, you'll prove the perpendicular bisector. But in grade 9, I just wanted to intro this terminology to you. All right, so that's it. Rest of the class and homework, page 9. So just these questions here, not a lot at all. You should be able to finish in class. And then tomorrow, we'll talk about inscribed angle and central angles. All right. Remember this package. All right. There's only 3 sections. After the circles, it's review already. All right. So there's only 3 sections. We did 2 already. So tomorrow we do the last section, and then Tuesday the review, Wednesday the test.